Hi, I'm Qiao. I would like to talk about our work, collaborative online learning with VR video and the roles of collaborative tools and shared video control. Virtual reality has the potential to revolutionize education in many ways. It can increase social presence, access otherwise inaccessible learning contexts, and help us remember the knowledge we have gained. But one major barrier of VR adoption is the cost of content creation. But fear not, with the proliferation of inexperienced consumer video cameras and various types of video editing software, using 360-degree video in VR has attracted more attention as an alternative method for instructors to build a realistic and immersive environment. It's a more user-friendly, realistic, and affordable way to create a digital experience compared to developing a simulated VR environment. However, current VR video viewing systems are not developed as collaborative tools to be used for educational goals. Most of them only provide an individual or asynchronous viewing experience, which is not ideal for pedagogical purpose. Research has shown that collaborative learning is better than individual learning in many ways. This highlights a research gap in the development and empirical investigation of collaboration VR video learning environments. That's where our work comes in. We design two modes to investigate the roles of collaborative tools and shared video control, then compare them with a conventional video player. Each mode contains a video viewing system and an after-video platform for further discussion and collaboration. Here is a demo of our three modes. Basic mode uses a conventional VR video player without any collaboration tool. This is what we have now to watch a VR video with the remote teammates. It provides several times control functions, play, pause, and think. In this condition, participants will use pen and paper for note-taking. We implemented two collaborative VR video viewing modes with different ways of video control. Synchronous mode had shared video control, such as play, pause, seek, among their group. That means after you pause the video, your teammates will also pause the video. The box shown in the air demonstrates the current viewport of a user. We provide three note-taking methods. Note-taking by screenshot, note-taking by speech-to-text note, and note-taking by drawings. Non-synchronized mode provides users with a collaborative VR video watching experience with individual timeline progress and control. It also provides a variety of functions that promotes in-VR communication, awareness, view sharing, and note-taking tools. We designed an in-VR discussion room to support the after-video discussion for non-sync and sync mode. For basic mode, we used an existing widely available online platform for after-video discussion. We also provide several functions in VR discussion room. Here we came up with two research questions. Research question 1: how does VR video delivery via existing technology compare to collaborative VR video delivery on measures of knowledge acquisition, collaboration, social presence, cognitive load, and satisfaction? Those measures are all closely related to the education. Research question 2: how does individual VR video control compare with shared video control on same learning-related measures we mentioned before? To answer our research questions, we conducted a 3 conditions within subject experiment with 54 participants, which is also 80 groups. We collected quantitative data from knowledge assessment, self-report questionnaire, and log files. We conducted one-way ANOVA to analyze this data, then conducted specific condition comparisons using a t-text with Cohen's d to measure the effect size. For fourth research question, we found that collaborative VR-based systems both achieved statistically significant higher score on the measures of visual knowledge acquisition, collaboration, social presence, and satisfaction compared to the baseline system. For qualitative results, participants reported the potential reasons such as lack of shared content and current technical obstacles, for example echoes, for lower scores of basic mode on collaboration and satisfaction. They also appreciate the in-VR platform's power to transmit and display visuals for after-video discussion, which explains the potential reasons for lower score of basic mode on the measures of visual knowledge acquisition. For research question 2, the shared control in sync mode significantly increased the ease of collaboration and the sense of social presence. In particular, shared control significantly increases view similarity and discussion time during the video. Based on the qualitative results, participants appreciated the ability to customize their pace to learn in basic and non-sync mode, but noted the communication suffered by lacking of shared content. In contrast, there is a more natural to start communication when participants were all there together and on the same page in the sync mode. This mode was perceived positively on communication comfort, but may reduce learning efficiency. Our work provides implications for design and research on collaborative VR video viewing system. First, balance the trade-off between learning pace flexibility and communication comfort based on teaching needs. The expectations for time flexibility and collaboration experience might differ for diverse educational activities and learning scenarios. Therefore, VR collaborative applications should decide whether or not to use shared control based on specific purpose. Second, providing note-taking methods appropriate to the modality of interaction and collaboration. Participants noted the importance of note-taking tools for remembering knowledge. Our results found that participants' preference for different note-taking techniques depends on the interaction modality and participants' video collaboration patterns. Third, supporting awareness visualization but avoid distraction. Awareness visualization enables social interactions by visualizing other status. Our results show that it helps participants create a shared content that promotes discussion. However, we found participants might feel distracted by dynamic awareness tools such as Viewport. Alright, takeaways for this paper. Collaborative VR video viewing system can improve visual knowledge acquisition, collaboration, social presence, and satisfaction compared to the conventional system. Shared video control in VR video viewing can enhance collaboration experience by increasing communication comfort, but may also reduce learning pace flexibility. Third, in VR platform for after-video discussion can enhance visual transmission and engagement, and improve the overall learning experience in collaborative VR video environment. That's all our presentation. Thank you.